I'm moving further. So I'm going to talk about why service virtualization and what are the opportunities where the service virtualization can fit into. So that is where I wanted to talk, for which I have to understand the current as-is scenario with whatever stage it is. So let's discuss a little bit about the problem statement or where we are at the moment. That is the slide which talks about constraints. Yes, look at this. This is the kind of, let's say, enterprise application. It's not a simple application where you have a web server or a database server or a web app and maybe. Let's say in a typical enterprise, you have various tiers and various blocks and various modules of the entire enterprise application stack. So as you see on the picture, you have, let's assume that you have a legacy application, you have an ERP application talking to legacy, and you have a database, and you also have a mainframe application, let's say. Now, when you start your software testing, I'm sure most of you might have had this problem. One of the tiers may be under construction. The database probably does not have database integrity or does not have the right version of database, or there is a wrong set data, which means you are not able to continue or start the testing. Then there could be actually another tier which is like mainframe, where you do not have access to 24 hours, 24/7, which means this again impacts the software testing. So let's assume that you have only 2 hours for the mainframe, and within 2 hours you have to complete the entire software testing. This is next to impossible. So thereby it impacts the quality. So that's why there are a few popular quotes that we have received, like I can't do anything until I have everything, and I never have everything. And I'm sure most of them would have been like software testing engineers have been waiting since morning, and at the end of the day is what the build comes or whatever, and then until that time you might have wasted the time, and you would probably should wrap up so faster in the late evenings and then do the build release of the particular day or of the particular release version. So how do we avoid this kind of problem? So this is the constraint that we had been facing as software testing engineers in terms of reduced schedule and non-availability of various tiers in this enterprise class application. And not only that, second set of problems and challenges, let's look at it. Look at that. I think I'm sure, having said that there are various tiers of application, you always have a huge set of developers and then pumping as much code possible into your configuration system, like SoSafe, Microsoft SoSafe, Visual SoSafe, or TFS, or WinCVS, or probably Subversion systems. So as and when they keep piling up code in the overnight, and they keep pushing it to the software testing engineer, and eventually it's going to be a nightmare for you to even to test everything integrated. So the testing definitely gets crunched up. The schedule gets crunched up, and I'm sure this is something that we had been talking years together about. No, developer has taken longer time, and we have very less time, and hence it's going to impact the quality. What are we going to do about it? So that is where the bottom right I have mentioned a kind of a schedule. What's the schedule given to you, and how does the integration testing get lagged up? Again, I want to set the context towards that enterprise class application where there are multiple tiers which will form an end-to-end workflow. So this is another context of which I want to explain the as-is situation, and hence we can realize and we can see the need of what we are going to talk with this service virtualization. So as we go forward, let's look at the old world first. So the old world is all about where you get requirements, you get the unit testing done, and you have a big bang approach. All of a sudden you get the entire set of code base, and you have to start doing what is called as functional testing. So what happens is until the code comes out, you don't know what defects are. So all of a sudden after unit testing, when you get the entire big bang build, you will get multiple number of defects, lots of defects at one shot. So why don't you probably keep finding defects before? So typically the answer for this kind of question is why don't you do a code review? Actually, code review is not the right way of actually validating your functionality, your testing. your functionality or your testing from the end user point of view, it always has to be done from the outside in. So that is the best way, and that's the best practices of the software testing. Just not that, there are more unknowns because you don't know, you have very less time, and hence, since there are more unknowns, you have a greater risk as well. And since you're going to start as a big bang, you will definitely need to have more software testing engineers, and eventually it's going to be more expensive task for you. So just not a big bang. After that, you do what's called as system testing. Then following the system testing, you have the other testings like just a message is getting right. You have given the integration testing, UAT, and you also have the OAT, which is operational acceptance testing. And somewhere somewhere you see also the performance testing, somewhere after some set of system testing done, which overlaps the period of system and UAT, you see the performance testing. Now, if you closely watch this figure, you have a big bang testing or functional testing. It could even be a system testing or a functional testing, everything starting right next to unit test, which means lots of defects overflew there. And then you have a quality gate, of course, because your system testing cycle is going to get crunched due to the development delays. You are going to definitely have a quality gate, and you are having UAT, and there are so many defects that the customer is going to find it out in alpha and beta testing phases. So this is the current asset situation. Now, in the new world, now how do you want to keep this in the new world? Let's look at it. I'm sorry, the UI is actually loading slowly. Kindly bear with me. Now look at that. In the new world, what happens is you have a new concept of what is called as integration testing, which means that, let's say in an enterprise class application, you have at least as many as 15 to 20 tiers. In fact, I know an application which has as many as 125 tiers as well. When I say 125 tiers, I don't mean the real platform or the main platform. Like for example, if I actually, from a browser, if I make a call to web server and it goes to app server and it goes to database server, that's the main platform for me. But if I talk to web server and web server in turn makes a call to an MQ server, message queue server, and that is actually in the branch. So try to picture what I talk. Okay, so let's say you have a main stack at the center, and you have so many other servers on your left and right or top and bottom, like a fishbone you can imagine. And you have MQ servers, you have something like a rules engine, or you have something like a batch functions, which actually comes, very handy for end-to-end flow. Then you will need to keep integrating one module with another module, or you will not be possible to do an end-to-end testing if those queue servers are not present, or if those batch servers are not present. So you need to keep doing these kind of end-to-end flow testing, but at the same time, the queue server or a batch job testing server is not present. So how do you do? So that is to answer that question is what we are introducing what's called a service virtualization, and that's where we fit in. So as in when you start doing integration test, an integration test here, I tell again, doing the test in the absence of one particular tier or another tier. So as and when you keep doing integration test for a set of modules, you can also do a performance testing. And when the new tier gets ready, what happens is you can also integrate that and then do another one round of performance testing, because all other modules are performance tested or all other tiers are performance tested, and you just have another tier added. And in case if there is performance degradation, it's because of the new tier that's added, which means your performance bottlenecks are also very clear, and it's very prevalent and very, it's like, very obvious why the performance lag is coming. So that way, we have seen the performance testing also, is going to be very much benefited by adopting this concept of service virtualization. So that's again in a context that I want to set where we wanted to go through. So in short, this is going to accelerate testing. It's going to reduce the cost. Let's see how. and it's going to reduce the risk because you have starting the testing as and when the unit tests are being done by the developers. Now let's get into some